the tranquil surroundings of Johannes Kepler University in Linz, technologists are immersing themselves in a torrent of water, flooding a valley in faraway Slovakia. The scenario has been created by a grid of computers that has integrated large amounts of data and then constructed a three-dimensional virtual demonstration. The work is part of CrossGrid. When floods happen, the emergency authorities urgently need to know where the water is going to go. This helps them understand who should be evacuated and where they should set up their emergency support resources. Prediction has become a complex task given the speed with which floods can develop. The CrossGrid project is pioneering a new approach.
So today big challenge is in this very fast or very quick time to predict river floods. River floods belong to very dangerous natural disaster which cause a lot of damage after them, and also connected with pollution, water pollution after this flood. To predict them in reasonable time, we need very powerful computing environment to compute all this prediction more or less in near real time. So for the prediction purposes, we need data from satellite, data from radars, data from the surface meteorological and hydrological stations, which prove some real situation on concrete place. And with this data, we are using for these prediction models, and this data we are using also for calibration of these models. For this computing environment must be very powerful, and grid technology is promising technology for that.
The bad thing about the grid regarding the flood is that you have access to the big power provided by a lot of computers connected to the grid network. So you don't have to use just the one supercomputer or cluster that you have at the institute. We have several applications: the meteorology, hydrology, hydraulics. Each of these has some requirements, so we have to wrap it and specify some parameters that are required, and we submit this package to the grid to be processed. Okay, we just don't have to care where it runs. We just say, okay, grid, compute this, and we get the results back. And that's the great.
One of the challenges posed by flooding is the speed that it can happen. CrossGrid is using the large storage capability of their grid to store hundreds of prediction scenarios.
For example, we can compute different scenarios for 25, 50, 100, 200, 500 or more 1,000 return period water, and this scenario we can compute and to save in the storage. And when some things happen, for example flash floods, this mayor of city or village can have a look on this scenario immediately, only download from the storage.
The local flood crisis management team, or the meteorologist, or the local officials are not concerned with how the grid works. They need to understand what the flood is going to be like. So the CrossGrid technologists have come to Linz to the university's virtual reality department to create a visualization of the flood that you can stand inside.
It allows the user to really get into the virtual reality scene, to get into the environment. So for this flooding simulation, you get the impression that you really stand in the scene, in the scenario. So you don't have to think about abstract figures. You're in the actual flooded area. You feel like you're there.
CrossGrid believes that there are two important areas of their work that also need to be developed. The first is to ensure that the huge investment made by the European Commission and others creates products and services that are commercially sustainable.
I am convinced that these products could be commercialized. Many river authorities exist, and each of these river authorities will need such software. Cities also will need such software. So I think that many customers exist.
The second focus is on the international collaboration that will become vital in the management of floods. Many rivers in Europe cross borders, and international teams need to create grids for specific rivers, like a Danube grid.
For example, so if something's happened in Germany, in some large rainfall occurred, therefore we must predict what happened in Bratislava, for example. Grid technology will allow to run different models and to compare results of the different models and to predict what happened in Budapest or other cities which are lying close to the Danube River. It is very important information.
CrossGrid has also looked at the potential of applying this technology to forest fires and predicting the actions of fires in large buildings. In all of these scenarios, the developers are pioneering a use of grid technology in a very practical way to save millions of pounds in damage and environmental pollution. As Europe forms its collaborative networks, we can feel safer in the knowledge that the grid is predicting the future and maybe even saving lives.